Welcome back to AI.Code.Cast, the show where we really dig into some cool coding problems. And today we're going to tackle valid palindrome.
Oh yeah, this one's a classic.
Yeah, but it's kind of deceiving at first glance. Like at first you think, oh, palindrome, easy, right? But there's more to it than just race car spelled the same way backwards.
Right, exactly. Because here we're only looking at the alphanumeric characters, and case doesn't matter.
So like spaces and commas and all that jazz, we just ignore them.
Yep, we're essentially creating like a special code view that only sees letters and numbers.
Okay, so like a man, a plan, a canal, Panama. That'd be valid in this case.
You got it. Punctuation's gone. Case doesn't matter. It's a palindrome.
So where do we start with this? Like if we're actually trying to code this out.
Well, I always like to think, how would I solve this manually before jumping into the code?
Okay. So if I was doing this by hand, I'd probably go through the string, get rid of all the non-alphanumeric characters, lowercase at all, then compare it to the original, reading it backwards. Seems kind of tedious, but it'd work.
Absolutely. That's basically the brute force method. Clean up the string, lowercase, reverse it, and compare.
But wait, aren't we creating like a whole new reverse string? Doesn't that seem kind of inefficient, memory-wise, especially with a long string?
You're hitting on a key point there, which is space complexity. In this case, it'd be ON, meaning the more memory we use grows directly with the input string lengths.
Okay, so longer string equals more memory used. Gotcha.
Yeah.
What about the time it takes to run this brute force method?
Time complexity is also ON. We're essentially going through the string a few times, clean it, reverse it, compare. But each of those takes time proportional to the string length.
So brute force is like the reliable truck. It gets the job done, but maybe not the most efficient.
Love that analogy. And this is where things get exciting, because there are ways to make it even better, both time and space-wise.
Okay, I'm all ears. What are these magical methods?
Let's think about palindromes. They're all about symmetry.
Yeah, the first and last character are the same, then the second and second to last, and so on.
Exactly. So instead of making a whole new reversed string, what if we compare characters from both ends at the same time?
I see where you're going with this. Like 2 pointers, one at the start, one at the end, moving inwards, comparing as they go. What if they hit a mismatch?
That's our red flag. Means it's not a palindrome. But if they keep moving towards each other, comparing successfully, and they cross paths,
Then we know it is a palindrome. So intuitive. And I bet it uses way less memory, right?
you nailed it. This is the two-pointer method. No need for a new string. Space complexity drops to 01, meaning we use a fixed amount of memory regardless of string length.
Wow, from a truck to a sports car. What of speed, though? Any slower?
Nope, still ON. We're basically going through the string once, just smarter this time.
2 pointers are winning me over. But how do we deal with those non-alphanumeric characters? Still got to clean the string first.
Nah, we handle them on the fly. If a pointer hits a non-alphanumeric character, it just skips to the next valid one. Filtering and comparing happen together.
Slick. So what if the palindrome has an odd number of characters? Where do the pointers meet then?
Great question. If it's odd, they'll end up pointing to the same character in the middle. No mismatches till then, it's a palindrome.
This is awesome. But I gotta ask, are there even more ways to solve this? Before we, totally jump ship from this 2-pointer thing, I'm thinking about Python. It's got all those weird tricks, right?
Yeah.
Anything we can use here?
Oh, you bet. You're thinking about negative indexing.
Maybe. Kinda. Remind me how that works again.
So negative indexing just means you can grab stuff from the end of a sequence like a string using negative numbers. So the last element is meg1, the one before that's meg2, and so on.
Right. I remember that now. But how does that help us with palindromes?
Well, picture this. We're looping through our cleaned up string, right? And we use this operator, the tilde. It looks like this.
Okay, a squiggly line. What's so special about it?
In Python, with an index, it basically gives you the mirrored index from the end, like a shortcut for reverse indexing.
Wait, so instead of 2 pointers going towards each other, we can use this tilde thingy in a single loop and compare from both ends.
Exactly. You compare the character at, say, index I with the character at index I. Mismatch. Not a palindrome. Get through a whole loop without a mismatch. Palindrome city.
That is super slick. So we're kind of doing the 2-pointer thing, but in a more Python-y way.
You got it. Shows how knowing the ins and outs of a language can lead to some elegant solutions.
Yeah, but this only works in Python, right? Other languages probably don't have this tilde magic.
Right. It relies on how Python does indexing and what the not operator means in this context. Other languages might have their own quirks, but this one's pretty specific.
Makes sense. It's like a cool party trick, but maybe not the most reliable tool in your toolbox if you're switching languages a lot.
Totally. Sometimes those language-specific things are fun, but the two-pointer method, that's like fundamental.
Yeah.
Works across the board.
Okay, so big picture time. We've got brute force, two pointers, and this Python tilde thing. When would you pick which one?
If you just want something simple and easy to read, brute force ain't bad. But if you gotta watch your memory, especially with big strings, two pointers is your winner.
And the Python trick is cool, but only if you're really comfortable with that stuff. A and D sticking with Python.
Yeah, good point. Pick the right tool for the job, right? Know what each one's good at and bad at.
This has been an awesome deep dive. We started with Palindrome, and now we're talking about like time, space, algorithms, and Python's weird quirks.
It's wild how even a simple idea can lead to all this other stuff, right?
Totally.
Yeah.
Reminds me that there's never just one way to code something. It's all about the situation and what you're trying to achieve.
I'm curious, though, what if we had to check palindromes in a massive stream of data? Like we can only see a little bit at a time.
Ooh, that's a good one. We can't really reverse an infinite stream, right? And the Python trick needs the whole string.
Right, those are out. But the two-pointer thing, I feel like there might be a way to adapt it.
Like imagine a window that slides along the stream, and we do the two-pointer check within that window.
Exactly. Left pointer at the start of the window, right pointer at the end, comparing as we go. What if the window fills up before we find a mismatch?
That IS tricky. Got to make space for new characters, but keep the old ones for the comparison.
Right. Feels like we'd need some extra tools to keep track of everything. Maybe a queue or a stack.
Those are good ideas. We might be onto something here, but looks like we're out of time for today.
Don't worry, we'll come back to this another time. This palindrome thing is way deeper than it looks at first glance.
It is. It totally is. Man, it's crazy how something as simple as a palindrome can take us this deep into code land.
Yeah, that's the cool thing about computer science, right? You start with one idea, and it just branches out in all these directions.
It's like those choose-your-own-adventure books, but for code.
Totally. Like with this palindrome thing, we've touched on string manipulation, memory stuff, even Python's weirdness, and it's all connected.
Right, and I think it's a good lesson for everyone listening. There's never just one right way to code. It depends on what you're trying to do, the language, all that jazz.
Absolutely. The best solution. It doesn't really exist. It's more like the best fit for the situation.
Okay, so as we wrap up this deep dive into palindromes, any final words of wisdom?
I'd say always take a step back and really get the problem before you jump into code. Don't get fancy right away. Even brute force, which might seem basic, can help you understand the logic.
It's like building a house. Got to have a solid foundation before you start putting up walls and a roof.
Exactly. Once you've got that foundation, then you can start looking at ways to optimize, like with the two-pointer method. That one's popular for a reason. It just works.
And hey, if you're feeling adventurous, try out those language-specific tricks like the Python thing we talked about. Just be mindful of the trade-offs, you know?
Right, like portability. Will it work in other languages? Readability. Can other people understand your code? Those things matter.
Absolutely. Every choice you make in code comes with a trade-off. Sometimes speed matters, sometimes memory, sometimes it's all about keeping things simple.
The key is to be aware of those choices, those trade-offs, and then make the decision that's right for that particular problem.
Love that. Okay, so final thought for everyone. Never stop learning. The world of code is always changing. There's always something new to discover. Even with a basic idea like palindrome, we've barely scratched the surface.
Right. There's always another layer to peel back, another challenge to tackle.
So to all the AI.Code.Cast listeners out there, keep experimenting, keep pushing yourselves, and never stop learning.
The deeper you go, the more fun it gets.
Couldn't have said it better myself. Thanks for joining us on this deep dive into palindromes. Hope you learned a thing or two.
Until next time, happy coding, everyone.